Hi and good morning once again. Thank you so much for continuing to watch our discussion. So this time we will have our last two topics in midterm, the lesson 4 and lesson 5. But first, let's discuss the lesson 4. So for science, we will be discussing strategies fostering thinking in the science classroom. So, critical and creative thinking require that students be actively engaged in learning science as opposed to the more traditional yet typical approach in which the student is on the receiving end of a lecture. So, the interactive classroom is one in which communication patterns involve students to teacher, teacher to students, and students to students. So the interactive classroom is a stimulating place in which students have been motivated to learn and are given the freedom to explore, discover, and inquire. So in the interactive classroom, you will find teacher-centered as well as student-centered activities. So in this particular lesson, we will be having all of these strategies involving how to interact with the students, what are actually the strategies that we can make sure that the activities that we are doing will be student-centered, and also partly there are teacher-centered activities that will actually help us in making sure that the classroom is interactive. Okay, so let's continue. So first is the art of questioning. So from the word itself, questioning, it is actually a topic wherein we need to check out what are actually the the importance of questioning when it comes to having interaction or interactive classroom. So according to many science educators, the art of questioning is one of the most important. I mean, the most important, because teachers sometimes ask over 100 questions in a classroom or a class session to encourage student thinking. Questions are a very powerful way to find out about student learning. And however, quite often, the teacher ends up answering his or her own questions for fear of waiting too long, or sometimes students are actually like having difficulty of answering the question. So in the end part, the teacher will need to answer the question. And this then results in teacher asking questions that solicit short answers and are and a consequence is that students really don't think much about thinking or about anything. So one of the best strategy in having an interactive classroom is questioning. So in questioning, you will a teacher like you will actually ask questions to the students, and it is very important that aside from using questions that are answerable by yes or no, or questions like what, where, when, it is very important that you would also add the question why and how, because in that way the students will be able to use their higher order thinking skills, and the classroom will have interaction, and in that way also they will develop their minds and their thinking. So sometimes it is really hard for the teacher to ask questions and then wait for a couple of minutes for the students' response, especially in this time of pandemic that we are doing online classes. So sometimes instead of waiting for the student to answer, teachers will actually proactively answer the question, because just like what I've said, very limited, or the time is very limited when it comes to online discussion. Also, another thing is, how can teachers' questions facilitate critical and creative thinking? Are some questioning strategies more effective than others? Let's examine some aspects of the art of questioning, so including types of questions, wait time, and strategies that will result in thoughtful and more in-depth student responses. So in this particular lesson, or in this particular part, we will have our discussion regarding what is actually the types of questions that we could use in questioning, the wait time in waiting for the response of the student, and of course the strategies that we could use in creating a better question. So first is categories of questions, or this are actually the type of questions. So there are many systems that teachers use to classify questions. Upon close observation, in most systems, questions are typically classified into two categories. Various terms are used to describe these two categories. So first one is the binary approach, and then the second one is the typical approach. So the binary approach is useful actually because two categories are more manageable for a beginning teacher to implement. While on the other hand, the typical approach, this is of using systems is with 6 categories. So for beginner teachers, or like for example you as a teacher in the future, it is easier for you to have the binary approach. Binary means it's two, so there are only like 2 categories that you could actually manage when it comes to doing questions. Well, if you're already like pro on your teaching, then the typical approach is actually better to use. Okay, so the category 1, factual, close, convergent, lower level, low order, low inquiry, while the category 2 is higher cognitive, open, divergent, higher level, high order, and high inquiry. So let's discuss what are actually the differences of these 2 categories. Okay, so category 1, this is what I've told you earlier, the answer to like what, where, when, or answer can be answered by yes or no. While on the other hand, in the category 2, it's higher cognitive. That means this question starts usually with why and how. And then closed-ended question, that is actually the questions that can be answered by yes or no. Like for example, are you happy? Yes. Are you sad? No. It's like that. And then the open-ended questions, that are actually the questions wherein the students need to think of what are actually the questions. This is also usually answerable by, starts with how or why, or sometimes you're actually asking questions to the students that they need to explain or explain thoroughly the answer that they have. And then the convergent and then the divergent. So it's actually similar. Lower level, and then the other one is higher level thinking skills, while the other one is low order, the other is high order, the other is low inquiry, and then the other is high inquiry. So these are actually like similar. So next is low inquiry questions. So these are actually the questions that focus on previously learned knowledge in order to answer questions posed by the teacher that require students to perform one of the following tasks. So these are the tasks. First is elicit the meaning of a term. So like for example, usually these are the questions that teachers asked. Like for example, what is the meaning of for example, science? So in that one, you're actually trying to get the information from the student if they are able to familiarize or at least understand what is the term. And then next is represent something by a word or a phrase. So like, for example, you will ask, can you give an example for this one? or supply an example of something, it's actually the same. And the next is the make statements of issues, steps in a procedure, rules, conclusions, ideas, and beliefs that have previously been made. So like for example, you will be asking the steps in the procedure, like what is actually the first step, second step. So that's also low inquiry questions. Next is apply a summary or a review that was previously said or provided. So this is like you will just say what have you understand, what is actually the summary of the story. The next is provide a specific, predictable answer to a question. So just like what I said, this is low inquiry questions. Why it's called low inquiry questions? Because it's not really asking higher order thinking skills, or it's not actually asking the student to like use their critical thinking skills. Next is high inquiry questions. So these are actually the questions with high inquiry or using the higher order thinking skills. So the following task will be performed. First is perform an abstract operation, usually of a mathematical nature, such as multiplying, substituting, or simplifying. So these are usually used in mathematics. Next is rate some entity as to its value, dependability, importance, or sufficiency with the defense of the rating. So with this one, you're actually asking the student to rate, like for example, the test that they were given or whatnot. And then next is find similarities or differences in the qualities of two or more entities utilizing criteria defined by the student. So normally these questions are like compare and contrast, or you will be asking them like create a Venn diagram. So that's like the higher inquiry questions. And then the fourth one is make a prediction that is the result of some stated condition, state, operation, object, or substance. So this one is like you are trying to ask the student on what are actually their prediction or probability. This is a higher order thinking skills already. Next is make inferences to account for the occurrence of something, like how or why it actually occurred. So it's very understandable naman, di ba? So next is, so low inquiry questions tend to reinforce correct answers or focused on specific acceptable answers, whereas high inquiry questions stimulate a broader range of responses and tend to stimulate high levels of thinking. So just like what I've said earlier, in a low inquiry questions, you're actually asking the fact, or it's actually factual answers. While on the other hand, the higher order thinking, higher inquiry questions, it would give the teacher the broader range of the response of the student, or how actually the student think of something or about the topic. So there is evidence to support the use of both types of questions. Low inquiry questions will help sharpen students' ability to recall experiences and events of science teaching. And then also these questions are useful if you are interested in having students focus on the details of the content. And high inquiry questions encourage a range of responses from students and tend to stimulate divergent thinking. So just like what I've said earlier also, that if ever, for example, you wanted to use the low inquiry questions, this is actually useful when it comes to like memorization, recalling of the experiences, and factual events. While the high inquiry questions, it's actually encouraging the student to use their critical thinking skills. Okay, so next is the wait time. So what is actually the wait time? This is the time wherein once a teacher asks the student a question, it will give them a couple of minutes to be exact to answer the question. So hindi naman pwede na you will provide a question to the student and then bigla-bigla mo lang din sila. Like for example, your question is, what is science? And then parang wala kang wait time. Like kailangan sagutin talaga ni student after you said the question. So this is not a game. So it's not really required to do that. So it is important that we have a wait time. So wait time is the knowledge of the types of questions and their predicted effects on student thinking is important. However, researchers have found that there are other factors associated with questioning that can enhance critical and creative thinking. One of the purposes of questioning is to enhance and increase verbal behavior of students in science classroom. So according to Mary Bud Rowe, she actually discovered that the following factors affect student verbal behavior. So there are actually tendency na kapag tinanong mo sa student and then you will not actually give them like the wait time. Yung maramdaman mo talaga na they are actually shaking and then maratel jud ka ng, I mean, yung tipo na parang hindi naman na nila masabi ng tama yung sagot. So yung ganun. So it is important that you will give them wait time. So in wait time, it would actually increase, it is increasing the period of time that the teacher waits for students to construct a response to a question. So you will like, for example, your wait time is normally 5 minutes. So after giving the question, you will wait for the student for like 5 minutes to answer your question. So in that way, the student will be able to construct the response and it would be as smoother as possible. Then next is increasing the amount of time that a teacher waits before replying to a student response. So part of the wait time also is when the the teacher wait for like a couple of minutes to reply on the student's response. So di din pwede na pagsagot ni student ng sagot niya is directly mo na lang nasasabi na ay mali yung sagot mo, ay tama yung sagot mo. So it's important that you will also like get the answer, yung tatanggapin mo pa siya and then internalize mo pa siya before you will provide a response. And the next is decreasing the pattern of reward and punishment delivered to students. So in this way, you can also like, decrease the reward punishment that you are actually giving to the students when you have the wait time. Okay, so next is types of question. This is the low inquiry convergent and the high inquiry divergent. These are the student responses here. These are the type of responses and these are the examples. So for the student responses, for example, in low inquiry, it would be recall, memorize, describe in own words, summarize, classify on basis of known criteria, and give example of something. So the sample questions for that is like, for example, how many? Define. In your own words, state similarities and differences of what is the evidence? What is an example? While on the other hand, when we do the high inquiry questions, so the divergent questions, student responses will be like create unique or original design, report inferences, prediction, judge scientific credibility, give an opinion or state an attitude, make value judgments about issues. These are actually open-ended questions. Question samples will be design experiment. What do you think is new site to support? So that's typically the question. Okay, so let's discuss. So Rowe or Mary has found that if teacher increase the time they wait after asking a question to 5 seconds or longer, then the strength or the length of responses also increases. So in this science classroom where the teacher is trying to encourage inquiry thinking, wait time becomes an important skill as well as a symbol of the teacher's attitude towards students' thinking. The teachers who are willing to wait recognize that inquiry thinking requires thoughtful consideration on the part of the students. So Rowe points out that teachers who extend their wait times to 5 seconds no longer increase speculative gain. So the use of science in the classroom can also become a powerful tool to enhance critical and creative thinking. So Rowe found out actually that if the Rowe actually found out that when we provide longer time to our students, like for example, like from 5 seconds or more, then the answer of the students is also longer because they could actually construct a better statement or better sentences when it comes to answering your question. Also, Rowe believes that teacher sanctions positive and negative rewards, if used indiscriminately, can reduce student inquiry. So at first glance, this doesn't actually make sense. However, Rowe has found out that when rewards are high, students tend to stop experimenting sooner than if rewards are low. When students begin attending to rewards rather than the task, then the spirit of inquiry tends to decrease. So that's actually one of the reasons why Rowe said that when you have wait time, the teacher who usually use the reward and punishment system will also decrease. Because if you would actually use the rewards and punishment system, there are tendency that the student will not actually focus on the task, but focus on the reward. So the inquiry there will be very low. So it's important that you do the wait time instead of doing the rewards and punishment system. You can still use it, but not really like 80% or 100% of all the tasks that you're doing. Okay, just minimum or minimize it. Okay, so waiting 3 to 5 seconds for student responses often does not evoke the kind of answers that are striving for. So how can you integrate knowledge of questions types and wait time to increase the likelihood that student responses are thoughtful and high level? So here are actually some of the strategies or suggestion. First is, after you ask the question, have the student pair off or form small groups to discuss the question. Then ask one member of each team to respond for the others. So this is typically an example of a group activity wherein you will provide a question to your students, and then that particular question will be discussed on that group. They will have brainstorming, and once they're able to construct the idea of that question, then you will select a representative that will discuss their response. Then second is using a multiple choice format. Ask the students to vote on these choices, and then ask some of the students to justify their vote. So another suggestion here is, like for example, you will ask the question in multiple choice question. Once they were able to select what are the questions that they have, then ask them to like justify why did they select that particular answer. So this is also an example for that. Next is, ask all of the students to write down a response and call on individuals to read out their answers. So this normally happens when actually I've been experiencing this one since elementary days. So a teacher will ask a question, and then he or she will ask the students to like write their answer or response. And then since there are very limited time, so all of the students will not really be able to read their responses, only some, and then they will, or the teacher will just take the answer sheet afterwards. Okay. So now let's go ahead and discuss the using examples to help students understand science concepts. So the word example comes from the word sample, which means a portion of the whole that shows the quality and character of the whole. So the use of examples is fundamental to helping students understand science concepts. So the teacher who identifies examples of concepts or asks students to cite examples of concepts is acknowledging that learning must be tied to students' prior knowledge. So using examples is a way to tie science teaching to the students' world. So using examples. Actually, I'm pretty sure you are very much familiar of what is example, right? So an example is like a model or an item, depending on what type of topics that you have. Example is actually the sample. Oh yeah, the sample of the topic that you are having. So, like for example, like what I am actually doing right now. So if ever, for example, your topic is, let's say, since this is an elementary topic or you will be an elementary teacher soon. So like, for example, your topic is five senses. So of course, you will find better samples or better examples in using that particular senses. So like, for example, you will have realia, like you will have flowers to add, and you will ask your students to like smell it. So that's also an example. So examples should be exciting and should be recognizable as everyday phenomena. So we use the acronym EEP to mean exciting examples of everyday phenomena. EEPs should be used to help the student understand science concepts and can exist in the form of an object, like for example, rubber door, wedge to represent an inclined plane, an artifact, a piece of battery to help student understand soil, a machine, photograph, a piece of technology, or a toy. So just like what I've said earlier, a flower, if you were having like a discussion about plants, parts of the plants, or if ever, for example, you are doing the five senses, so that would actually trigger the nose. So that's an example of examples. Okay, so next here, one way to help you think about examples is to examine a list of categories and use it as a stimulus for connecting these categories with science concepts. So what kinds of examples can you generate from the following list? So like for example, detergent, when you ask your student, can you provide any examples of detergent? Of course, they will like say, Mom, Ariel, Mom, Diet, Mom, Wings, Mom, Pride. So that's already an example of detergents. You will ask, how about household chemicals or like fertilizer or vegetables or flowers? So they will provide you a lot of examples of that particular topic. So examples can be used deductively or inductively to help students understand concepts. However, it is important to keep in mind that we have discussed about the learning cycle and the generative model of learning. Okay, so like for example, this one, teacher identifies concept, and then teacher identifies examples and phenomena related to concept, and or students explore examples and phenomena direct. And then last is the students connect examples and phenomena to concepts. So normally this is actually what will happen when you do a task, like you will find a topic or a concept, and then the student will be able to provide those examples. Okay. So examples, as you recall, cognitive psychologist theories that students construct their knowledge of concepts and must do so through their interaction with ideas. So phenomena and people in the deductive approach of using examples, learning begins with the idea, principle, or concepts, and is then followed by an exploration of examples and phenomena. So I will not really dig deeper about the examples because I'm pretty sure most of us are already familiar on what is examples. Okay, so that is actually the end of this particular topic. So once again, thank you so much for joining our discussion today, and please study for your examination. Thank you.